Okay, let's dive into this. If you work in tech, you have seen this promise a million times. 99.9% availability. You know, three nines. It just sounds so solid, so reliable, practically perfect. But what actually happens when your app depends on, say, 3 different services that all promise you that same 99.9%? Well, the answer is probably not what you think.
So let's frame this as a little puzzle. Your app is pretty simple. It's got a CDN for the front end, a back-end API, and a database. Now, each of your providers guarantees you 99.9% uptime. So the big question is, does that mean your app as a whole is also 99.9% available? Your gut might say, yeah, of course, but you'll see the math tells a totally different and much more interesting story.
Now, before we solve this thing, let's just make sure we're all on the same page with the lingo. That 99.9% promise, it has a name. It's called a Service Level Agreement, or SLA for short. It's basically a contract, a formal commitment from a provider about how much uptime you can realistically expect. It's pretty much the bedrock of reliability in the cloud.
To put 3 nines into perspective, what does it actually mean in human time? Well, it's not perfect, not by a long shot. A 99.9% SLA allows for about 8.7 hours of downtime over a whole year. You know, that could be a few minutes of blips here and there, or it could be one really, really bad day for your users. So keep that number in your head, 8.7 hours.
Okay, so let's trace a single request through our example app. A user clicks something. First, that request hits your front-end CDN. But the CDN needs data, right? So it has to make a call to your back-end API. And where does the API get its data? Well, it has to go and query the database. See the pattern here? It's like a line of dominoes. One has to fall for the next one to go. These are all dependent steps.
And that brings us to the most important idea in this entire explainer. You have to think of your system not just as a collection of services, but as a chain. And for your user's request to actually work, every single link in that chain has to be up and running. If the CDN fails, the chain is broken. If the API is down, the chain is broken. If any one of them has a problem, the whole request fails for the user.
Okay, so this is the crucial part. We can't just look at that 99.9% number and assume it applies to our whole system. It doesn't work that way. We have to figure out the total, or what we call the composite availability of this entire chain. So, how do we actually do that? So here is our setup. We've got our 3 components lined up, and each one individually is giving us that 3 nines promise. But the big mystery we need to solve is that question mark down at the bottom. That's the number that really matters. It's the end-to-end availability that your users are actually experiencing.
Now, here's the trick. You don't average these numbers. You have to multiply them. So the first step is to convert the percentage into a decimal. For our first component, the CDN, 99.9% becomes 0.999. Simple enough.
Next, we bring in the second link in our chain, the API. We multiply our first number by the API's availability. So we've got 0.999 times 0.999. And you can already see where this is going, right? The number is getting smaller.
And for the final piece of the puzzle, we multiply by the availability of our last link, the database. So it's 0.999 times 0.999 times 0.999. All right, you ready for the big reveal?
And there it is, 99.7%. Your system's actual real-world availability is not 99.9%, it's 99.7. Just by chaining 3 highly available services together, we've dropped from the gold standard of 3 nines all the way down to something that's, well, it's closer to 2 nines.
So you might be thinking, okay, 0.2%, what's the big deal? Well, let's translate that percentage back into actual downtime. Remember that 8.7 hours we started with? At 99.7% availability, your total potential downtime for the year jumps to 26.3 hours. That's triple the downtime you might have planned for. That is a massive difference when it comes to user experience, trust, and, your bottom line.
If you take only one thing away from this whole explainer, please let it be this. For any critical path in your system, the overall availability is the product of all its dependencies multiplied together. It's not the average. And that means your total availability will always be lower than the availability of your single least reliable component. So what are the big lessons here for anyone building software? Well, first, every time you add another required service in a chain, you are actively lowering your system's maximum possible uptime. Each new service is another potential point of failure. That's why it is absolutely crucial to do the math and calculate the composite SLA for your most important user journeys. And never, ever make the mistake of thinking that a system built on highly available parts is, by default, highly available itself.
And that really leads to a fundamental shift in mindset. Understanding this math forces you to stop just architecting for the happy path, where everything works. You have to start architecting for failure. It pushes you towards building more resilient systems with things like smart retries, graceful fallbacks, and redundancies. So the real question I'll leave you with is this. Knowing how the numbers truly stack up, how will you design your next system differently?